Question 6 is on the topic of polynomial. The topic on polynomials is quite isolated. So this is the topic where you start by learning the long division and you learn about identities. So the identities is the one that you are using it in partial fraction. So this topic is usually mixed with partial fraction at the end of it. And then you also learn the remainder theorem, and the factor theorem, and also the cubic equation. So because this is a very isolated topic, if this question appear for paper 1 of amath, it doesn't appear for paper 2. Okay, so one of the things will be some students didn't recognize that it's a polynomial question. Okay, so the theme will be they talk about remainder. Okay, so you are given a cubic function fx, and the question is, first of all, I need to show a cubic equation in A, and the given information is regarding the remainder. Okay, so there's two situations. So this fx can be divided by this, or this fx can be divided by 2x minus a. So there are some relationship about their remainder. So the remainder here is actually 4 times the remainder here. So for those who have forgotten, you might forget, how am I going to get the remainder? I can't even do a full long division. Yeah, I can't do a full long division. So this is where the remainder theorem comes in. So the remainder theorem says that you set the divisor to 0. The remainder that you will like here is f2a. So the x is being substituted. So what is the meaning of f2a? That means all the x here, you're going to change it to 2a. So that can be a lot of careless mistake. So that will be this remainder. Then what about the other remainder? So we do the remainder theorem one more time. Set the divisor to 0. Get your x. The remainder in this situation will be f(a) over 2. So meaning all the x is being replaced by a over 2. So it's very easy to make careless mistake. There are fractions involved for that. So how are you going to show? Okay, this is so you are going to take this, simplify first, of course, equal to 4 bracket with this. If nothing goes wrong, you will get this part. So I already worked out in my answer. For your case, you can try. See whether eventually it leads you to that. So even if you couldn't, you just continue. Even if you couldn't, you just continue to use the cubic equation in the next part. So for solving of a cubic equation, the standard step is to find a factor first. So usually I will define as a function. So it is a function in A, and I call it G. So this is the name of the function. So fx, just now it was fx. That means the name is actually f. The variable is x. So you actually need to do a trial and error. So the first step, you got to find a factor. The method to get a factor is do a trial and error by punching calculator. But how are you going to punch? You got to use the last number. Think about the factor. So you will try to punch calculator. So you try to do something like, so you will use A. It can be 1 or -1. It can be 3 or -3. It can be 7 or -7. It can be 21 or -21. So you're going to try punching calculator. So what is G1? What is G -1? What is G3? So there's a lot for you to try. You don't need to show the trying. You have to punch calculator very carefully. So the aim of the calculator is to get 0. So which is the one that gave you a 0? So the implication of getting a 0 means 0 remainder. No remainder. So what is the value of A that doesn't get you a remainder? So you do your own trial and error based on the last number. So after you do the trial and error, okay, so in this case, you will get, this will actually give you a 0. So this will actually give you a 0. You can give it a try. Okay, so no need to show everything. You can just say something like, by trial and error, by trial and error, G1 equal to 0. That means you put in A equal to 1, it gave you a 0 remainder. So if you work backwards, this is the function. So this will be the factor. So A -1 is a factor. So that is the trial and error step. Followed by, it can be a long division. So typically, the foundation method is to execute a long division. And you must get a 0 remainder because we already know that it will be a 0. So you must do your long division very carefully. In this question, I'm getting this. So what is the implication of doing this? That means your original cubic function is a product. So that means, right, if you would like to solve this equal to 0, it actually become this equal to 0. So you'll go for first bracket equal to 0, second bracket equal to 0. The second bracket is a quadratic function. So you can even use your quadratic formula. So in fact, right, your job is to explain whether you agree with Peter or not. Because Peter claimed that A had more than one possible value. So what Peter did was, he said that there's more than one possible value. So if you want to decide whether you want to agree or not, you have done the solving and you see, do you get this? And is there more answers here? So at the conclusion, you should say whether you agree with Peter or not. So if you agree, that means you get more than one answer. But if you don't agree, that means you are getting otherwise. Okay, so you're going to try out the steps. So this question cover remainder theorem, factor theorem, and the cubic equation.